But you need to read this question carefully to really understand what's going on. And I'm going to add some notes to the equation to help me work this out. So the first one is this hydrated compound is a blue. So I'm going to put here to remind me it's a blue solid. And the anhydrous, anhydrous means without water, is white. So you can see what they've done is they've taken this blue chemical that's got water, it's hydrated, and produced a white chemical with the water now separate. And that change in structure has caused the colour to go from blue to white. It says heat energy is needed to convert the hydrated into anhydrous. So what I've got to do here, if I'm going to go that way, I've got to heat this reaction up. And when I heat this reaction up, all I'm doing is getting rid of the water and leaving the copper sulfate on its own with the water being removed. And it says this reaction is reversible, as you can see by the sign. So the first bit says devise an experiment to show this reaction is reversible. So what I would do, first of all, is I would heat the hydrated, and I'm going to use the formula, I would heat the hydrated copper sulfate. And what I would see is it would turn from blue to white. So it'd go from blue to white as that happened, and you'd probably see steam being released as it does that, because this here is going to be released and that will come off as steam. Okay, then to show it's reversible, what I would then do is I would add water to the copper sulfate. So if you look, to make this reaction come backwards this way, if I add water to this, it will reform this compound. So I'm going to add water to copper sulfate. The white colour would turn blue, and that's as the hydrated, so the copper sulfate hydrated, is formed. So we're making it go backwards and forwards as we do that. And again, what you would see, if that way is heat is being added, coming back this way, you're going to get heat being released, because that would be endothermic in its process. Okay, carrying on. Same here with this one. Write some information on, and then it'll help you to do this. So hydrogen reacts with iodine to form hydrogen iodide. Iodine gas is purple. So here I'm going to put down this is purple, and hydrogen iodide gas, is colourless. So that is colourless. Okay. They're placed in a sealed container. Hydrogen is left until the equilibrium is reached, and the conditions favouring the forward reaction are put in place. So I'm going to make this reaction go more that way by doing whatever the favourable conditions are. Explain what you would see. So if I make the reaction go this direction, my purple chemical, the iodine, is going to react more with the hydrogen, and therefore I'll get more of the colourless hydrogen iodide produced. So my purple colour will start to fade. So that's all I need to say. So I would say that the purple colour will fade. Why is it going to fade? Because there is less I2 as it reacts more with hydrogen. Okay, right, the final one. Calculate the number of atoms in 1 mole of copper oxide. Okay, so atoms combined, so it's all the atoms inside it. So first thing we need to do is spot that copper iodide contains one lot of copper and 2 lots of iodine. So it's got inside it 3 moles of atoms. So I want to know exactly how many atoms there are. All I need to do, number of atoms, is take the moles and times it by Avogadro's constant. So because there are 3 lots of moles of atoms in there, times it by Avogadro's constant, which is in the question, and I get that, and that's going to give me 1.8 1.806 times by 10 to the power of 24 atoms.